So in this video, let's talk about the multiplication and division of surds, irrational numbers. Last video I discussed about addition and subtraction comparing with algebraic expression. If you haven't watched, please go back and watch and then come back to this. So concept wise, let's take two surds, two irrational numbers, root 3 multiplied by root 5. So we discussed in our last video that this is my radical symbol, and then here is the index, nothing is there, it's 2. So in this case actually that radical symbol with the index should be same, so that I can find or I can multiply the numbers inside which are radicand. So in this case actually it's going to be square root of 3 into 5, which is going to be root 15. So that's a simple, very simple understanding. What cannot be done is, let's take square root of 3 multiplied by cube root or fourth root of 5. Symbol is same but my index is not same, so I cannot multiply these ones. So this is not possible. So now if I compare this with algebraic expression, let's just take root 3 as x, root 5 as y. So what would I have done? X into y, that's xy here, but that's algebraic expression, there is no root, nothing is there, so I've just multiplied. This is just the product. Let's take another instance, something with the number outside. 2 root 3 multiplied by 5 root 6. So now what did I say? Radical with the symbol is same, radical with the symbol is same, so that means I can actually multiply. What happens to the numbers outside? You multiply numbers outside, and considering the condition, multiply the numbers radicands inside. So following that, numbers outside 2 into 5 is 10, square root, and the condition with the index is same, 3 into 6 is 18. So you can leave it at this. Last video also I had clearly mentioned that if you can simplify, you must simplify. So that's what actually most of the time they are looking for. Answers might be, if it is objective type questions, you might have any type of answer with simplified, without simplified, but intentionally it will be simplified. So this is, if I prime factorize, this can be written as 9 into 2, but actually not prime factorized. It should be 3 into 3 into 2. 9 can be written as 3 square 2, or square root of 9 is 3, so that 3 will come out. That will have 10 multiplied by 3, root 2 stays as is. This will be 30 root 2. Remember, that's a simplification process. It's there everywhere across addition, subtraction, multiplication and division. So now let's get back to division. So what we would have done if it is division algebraic expression? 2x multiplied by, divided by 6x. Numbers separate division, 2 1s are 2 3s are, x power is same, so it gets cancelled. But again you have to keep in terms of the mindset of exponents, because if the powers are there, then you need to cancel only equal number of variables. Let's take an example. 5x square divided by 3x. 5 and 3, both of them are prime numbers. In this case I will not be able to simplify that fraction, particularly 5 by 3. X and x, there are 2x here and 1 here, so that means I can take out 1. If I take out 1, 1x will be left. If it is exponent, it would have been x to the power 2. This is power 1. Law of exponents, if I apply 2 minus 1, that will be x to the power 1. X to the power 1 is only 1x. This will result as 5x by 3. So equal number of x are actually cancelled. So let's take surd division, root 5 divided by 5 root 5. So as far as I can see, if I consider this as x and x, only those will get cancelled. My answer will be 1 by 5. So let's just say what will happen if it is root 5 divided by 2 root 5 divided by 3 root 6. They are not same. In this case actually they should be same, as in terms of additions. If you remember, the radical symbol with the index and the radicand should be same. I cannot cancel this and this. I should keep them as is. 2 by 3 will also remain as is, so that answer nothing will happen unless and until you rationalize the denominator. If you have trouble rationalizing denominator, I have some other videos on rationalizing denominators. Please watch them as well. I have given 2-3 different types of examples. So now we'll try to divide something different. So what is not possible? Let's talk about that first. Root 5. First we discussed about this, and root 5 and 4th root of 5. I cannot take out this because it has to be with the same index. Because sorry, the 4th root of 5 is entirely different than root 5, so I cannot cancel them. So keep that in mind. Let's take another one. Root 3 divided by 5 root 3 divided by 6 18 root 18. So according to whatever the condition I have mentioned, nothing gets cancelled. I should be writing as is, but always you have to keep in mind, if anything is possible that you can actually find out the root or simplify, you have to simplify and see whether you can actually do it. So let's see. 5 root 3 is already a prime number. I can't find root 3 as is, so that is stays as is. And 6, this can be written as 9 into 2, and 9 will come out. That is 5 root 3. Square root of 9 is 3. 6 into 3 is 18. Root 2 stays as is. But in this case, 5 and 18 I cannot cancel. Root 3 and root 2 I cannot cancel. So that's the only simplified term, unless and until I wish to continue with rationalizing the denominator. Let's look at one more last. So let's see, root 15 divided by root 27. Let's take that. I have intentionally taken some number in this case because so that you know different ways of actually doing that. Let's see, but this is entirely different because not all the time you will get exact 1 2 3 steps. So root 15, root 15 I can prime factorize as 3 into 5, so I cannot take out anything, so that will be 3 into 5. I'll keep it as is. The reason you will get to know in your next step. So 27 is 3 into 3 into 3. 3 3 is a 9, 9 3 is a 27. So that will be 3 into 3 into 3. But 3 into 3, 3 square, which is 9. Square root of 9 is 3. So that means 3 can come out. 3 into 3 is 9. Square root of 9 is 3. 3 comes out. And one more 3 is left. In the numerator, I still have root 3 into 5. Remember, in the first one, what we did, root 3 multiplied by root 5, radical and index was same. I was able to multiply 3 multiplied by 5, it is root 15. If I were to write it in reverse, that is what I need to be able to write. So if I am going to think in that way, this will be root 3 into root 5. I did not change the value of root 15, it's still the same. The only thing is I am trying to simplify the given fraction with surds. So that will be 3 root 3. Root 3 gets cancelled. So I will be left with root 5 divided by 3. So these are all the different options you have when you simplify surds with the different operations. I hope you understood. I've given different examples, and if you have any doubts, just put them in the comment below. And if you like the video, subscribe to my channel and then hit that like button. I will see you next time.